Speaking of hemispheres, did you know the moon in the sky looks like this in the northern hemisphere, like in Canada, but it looks like this in the southern hemisphere, like in Australia? It's upside down! And while that is a fun fact, it's even more fun to understand why. And this is why. As we all know, the Earth is a sphere. So if you were Superman standing at the North Pole in the northern hemisphere, you'd look like this. But if you were Thor standing in the southern hemisphere in Antarctica, you'd look like this. Now, of course, the moon over here orbits around the Earth like this, and I'm gonna add an arrow to it to help us with orientation. And so to Superman at the North Pole, that arrow would point up, but from the perspective of Thor at the South Pole, that arrow would point down from his perspective. And now I know what you're thinking. If all that's true, then which way would the arrow point if you're Spider-Man standing here at the equator? Well, according to our model here, it should be sideways. And sure enough, here in Ecuador at the equator, I'm happy to report that the moon does in fact appear to be sideways. For fun fact 2 of 7, if you just stick 2 pins into some cardboard like this, and then connect them with a string and trace it out, you get my favorite geometric shape, an ellipse. But there's something really special about these 2 pinholes. They're called the focus points, and any straight line you shoot out in any direction from one of the points will bounce off the wall of the ellipse and always hit the other focus point. And here's proof, because I've got a laser pointer at one focus point, a ball of wax at the other, and a mirrored surface all along the interior wall. And now you can see no matter which way I point the laser, it always bounces off and lights up the wax. But here's the really cool part. If you build an actual full-size room in the shape of an ellipse and then you stand at one focus point, you can hear even the faintest whisper from anyone standing at the other focus point, even hundreds of feet away, because all the sound waves bounce right back to your ears. In fact, this actual ellipse-shaped room was built by John Quincy Adams in the US Capitol building. And legend has it, he was a master at anticipating the moves of his opponents plotting against him on the opposite side of the large hall. And now that you know the physics involved, it should come as no surprise that John Quincy Adams conveniently placed his desk right on top of this leftmost focus point. Next up at number 3, everyone knows when you slam on the accelerator pedal in a car, the stuff inside slides backwards, and then when you slam on the brakes, the stuff inside just keeps moving forward. Including you, by the way, which is why we wear seatbelts. So then why the heck, when I'm driving to the birthday party and I have to slam on the brakes, does the cake slide forward, but the balloons actually move backwards? And as for the cake sliding forward, well, that's just Newton's first law in action, which basically says all stuff is kind of lazy and wants to stay still unless a force comes in and tries to move things. And then Newton's second law tells us that the more you weigh and the more mass you have, the more force is required to even get you to move. But here's the thing we sometimes forget.